And the last day to withdraw that information here, that is my name, Hieu Tran. You can call me Hieu Tran. I came from Vietnam, that's why my name here. My office hour, sorry, my office location, my email address, the phone number, that is the first time I teach in this campus. That's why I have not got the extension for my phone number. Yes, so right now I use the school phone number, but when I got the extension, I will update it here. My office hour is Monday from 9 to 2, and Tuesday and Thursday from 9 to 8, and Friday from 1 to 2 p.m. So you can stop by anytime during my office hour. You can need my help, or you can send me an email or inbox me whenever you need my help. And my information about my supervisor here, and his phone number, his email address. I also have the office hour for his here. And for this one, if you need support, you can contact the lab tech, the guy over there, or you can go on this website here. And for this class, require take or other instructional material and supply. For this one, you do not need a physical book. Everything is already integrated into the MyTab. So basically, if you want to go to the MyTab, you click on the module here. You scroll it down, and you see start here to access send get MyTab here. You click on this one, and it will link you to the send get MyTab. Okay, so in the send get MyTab, you see they also break it down into the unit, and when you click on specific units, you have the textbook reading, right? And you have the some of the code here. You have many assignments in the second, but not all of them are great. Right? So we see whenever you have count toward grade, that one is reflected in the Canvas grade. Right? And you see that is the way you navigate to the book here. Let me come back to the syllabus. Okay, so the course outline, you have the sum of objective here. You will cover all of them into this class, and how the point distribution. And in that one, you have introduction discussion. You have the one discussion here at 10 point, and content discussion. You have 6 of them. Each of them is at 20, and you have the quizzes, 6 of them. Each of them is 20, and non-programming exercise. You have 3, and each of them is 20 here. And you have the debugging exercise, assignment, final project, and the final exam. We have a and how grading scale work. You know that, right? That's the policy here. Whenever you have greater than or equal 90, you have A, and so on here. In order to pass this, you must earn D here. That means the overall grade must be greater than or equal 60. And this is a Learn Anywhere class. That means you are required to join class. It can be required. You can join class on the campus or on the Zoom meeting here, but you are required to join class here. And our assignment and grading, that I just reviewed it here already. Right? And due date and deadline. So for each of the module, you have this one is a 8-week class, right? So each of the week, you have the sum of the specific assignment, and you can check it in the calendar here. When you click on the calendar, let's see, click this one here. Right? So yeah, you see for this week you have some due date here on the 25th and the 28th here. So remember, keep track of the calendar to see what is the due date for this week. And select and make up a policy. For any less assignment, it will automatically grade to 0. So for any reason, if you have something to have the less submission, you have to tell me. You have to inform me first. Right? You have to seek prior approval, private approval from me before the remember that you have to seek prior approval from me before the due date, not after that. Otherwise, we got the 0 here. And you have the non-attendance drop. It's August 29. Last day to withdraw is October 2nd. And the cross communication, you have multiple way to contact me here. So here is a sum of the option here. For any reason, if you need my help, right? The first thing, you can email me or you can inbox me. You can join my office hour. And lastly, in the case you cannot join my office hour or you cannot join my office hour via the Zoom meeting, you just send me email with the multiple available window time. I know that some of you have the full-time job, you have the part-time job, and sometimes you are not able to join my office hour. So send me the available time so I can choose one of these that work best for you and me. Okay. And you have the sum of the policy here. It's not it's a general policy. So if you need more detail, you can read it in the syllabus here. And you see on the cost summary also we have the specific detail for this one. Any questions so far? Okay. Now go back to the announcement here. Let's see what we have the first announcement, right? So begin with the syllabus, we did it, right? But all of the weekly course content is located in the module. So think about this one is the first week, right? So if you want to navigate what is in the first week, you have to go to module here, and you scroll it down. You could scroll down. This one break it down into the 8 module because you have the 8 week here. So for each of the weeks, the first one here, right? See, you have the first week. Now you have something to do. The first one is the learning activity, right? You have to click on the learning activity. What you have here is the learning activity. What you have the things that you are required to read before you work with the assignment here. And the learning activity, textbook reading, a supplemental material here. And when you're done with everything with the reading, here is assignment here. You have the discussion, you have the debugging exercise, you have some of the assignment with Raptor and executing code in the Python here. Now, I go over to every single one of them here. Now, we go with the discussion here. One thing you have to remember about the discussion here, for every discussion, you have 2 due dates. Remember that you only have the 2 due dates for the every discussion here. But in the Canvas, it's only allow me to set 1 due date only. That's why I have to highlight it. For every discussion, you have the 2 due dates. And the initial port here, normally you have initial port, it's due date on Thursday of the week. And you are required to respond at least to other students. And the response here, it is a due date on Sunday. So keep in mind that I believe that I had the announcement here also. Here, due dates for every discussion here. But remember, for every discussion, you have 2 due dates. And the initial port is on Thursday. And you are supposed that you have to reply at least 2 other students that you want to submit. That's something you have to remember about that one. Now, come back to the module again. That's the first thing about the discussion, right? About the discussion, here's the first thing. The same with this one here. Now, for each of the module, you have something work with the debugging exercise. Debugging exercise is something you have to understand about the pseudocode. We learn about pseudocode later today. Right? And in order to work with the debugging exercise, you have to click on this one here. You have to click on this one and have the link to the SendGate, and you download the file into the computer. Yes, so you have the option to save it here, right? So when you save it in your computer and you open it here, that is something you have to do, right? So you have the debugging instruction here to tell you what you are supposed to do with this one here, right? Supposed to do with this one. Now come back to this one. So basically, for every week, you will have the 4 debugging exercise, and you are supposed to correct all of them. So think about this one here. Click on this one. You have to navigate this one, and you have to find out what is wrong with this program, and you have to correct it and submit it. That's about the debugging exercise. Now you move to some of the other one. This class you are required to install Raptor on your computer. So if you have a Windows computer, it's okay, but on the Mac computer, it's not. Raptor is not support. So you have some option here. You can go to the campus here to work on the computer on the campus, or for the Mac you can install the VirtualBox. You download the Windows, install Windows on top of the VirtualBox, and again, finally you install the Raptor on top of the Windows. Okay. But if you need any help from me to install Raptor on the Mac, you can study after the class. I will instruct you how to do it. And you have assignment with the Raptor. Raptor is a simulation coding program. It works with a flow chart. So I will have everyone here on the class later on this class. And for executing code in the Python here. So when you click on this one is linked to the SendGate. Link into the SendGate. Okay. And please start assignment now. Okay, so for this one, actually you work with the Python in virtual machine in the SendGate. You link to the virtual machine in the SendGate here, and you look on the left, it's an instruction. You have to follow all the instruction here in order to do with this program. In order to do this program. So when you've done everything with this program here, if you want to submit it, you have to click on this one here. You click on the task here, right? And in that one, you have the option to run check here to see what is a completion here. I did not do anything, that's why I have 0 here, right? But it's up to you. You can have 75 or 100. So when you've done it, you have to click the submit here, right? So how it works? Basically, all of the program here, when you submit it, the grade will be recorded into the SendGate, and it will automatically sync into the canvas, right? So for that reason here, remember that for that reason, whenever you want to keep track your progress, you have to check into the grade here. Right? So remember that whenever you want to check your progress, you check grades in the canvas, not in the SendGate. Remember that because in the SendGate it is sync to the canvas here. Not all of the assignment in the SendGate. Some of them in the canvas and some of them in the SendGate. But anyone in the SendGate will sync to the canvas. So ultimately, if you want to check for the progress, you go to the grade here. Now, the last one of the assignment here. This one, the question again. This one linked to the SendGate, and also it will be synced right to the canvas. Okay. Any questions so far? Let me know. Okay. So if you do not have any question, let me go with the slide here for this week. Also, guys online, do you have any question? No, it's not always recorded because it is a Learn Anywhere class. So you are required either to join it on the campus or on the Zoom meeting. I only record and only give it to you in the case you have some specific problem. Say you have the sickness or something like that, right? But not always to be able to you. Okay, so objective for this one, you learn about the computer system, simple programming logic, step to involve in the program development cycle, pseudocode, a statement and flowchart symbol using the Sentinel value to end programming and user environments and the evolution of programming model here. We go over one by one of this one. First one, understanding the computer system. Computer system is a combination of the component required to process and store data using the computer. So the two most basic function of the computer is the processing and storing. Right? You do something processing and you want to store it for the later using. And you have the hardware. Hardware is everything with the physical equipment here. You can see everything here, right? Monitor, keyboard, and mouse, and so on. And software is a computer instruction that tells the hardware what to do. Is that you have program. Program is a set of instruction to written by the programmer. So you are now, you can think about you are as a programmer. You write the program to tell computer what to do, right? And the programming, it is the process of writing software instruction. And computer hardware and the software, it accomplishes the three major operations. The first one, input. Input, that means you get input. It can be from the user or it can be from the drive here. It can take any information. That is you got the input. So when you got the input, you do everything the processing, right? Manipulating it, the processing here. The calculation and comparison performed by the CPU, central processing unit. And now we're done with the processing. The last time you deliver the output here, right? User the output. It's a resulting information that is sent to the printer, monitor, or storage device. And nowadays, the cloud is very, very normal, right? If you want to store information, you can store it in the cloud. Now, component of the computer, you have the central processing unit. It's a CPU. Think about it, the brain of the computer. Do everything is the processing. And you have internal memory, you have RAM, that random access memory, and you have ROM, it's a read-only memory here. Random access memory is that you can think about the scratches here. So when you write it, but when you exit program or you reset the computer, everything gone. But for the ROM, it's everything, it's a read-only, that's why normally it controls the hardware and you cannot delete it here. For the mass storage device, you have the magnetic. Think about the hard disk drive here, optical, you have the CD, you have SD, and nowadays you store a lot of information in the cloud. The system unit, you can think about, okay, something here, right? It store everything about, the CPU, internal memory, and the most mass storage here. Input device such as keyboard and mouse, and output device, you can have the thing about monitor and printer here. CPU is the brain of the computer, right? You have to receive the program instruction, perform everything about the arithmetic and logic operation. You learn about what is arithmetic and logical operation later in this class. And control other computer components and consists of million of the transistor on a single microchip and plug into the motherboard here. And the speed of CPU is measured in the gigahertz. This one actually is not really relevant to this class, so I do not want to go in detail here. If you want to learn more about hardware specific, you learn about IT support here, about ITSP classes. That's why I do not go into detail here. And ROM, read-only memory, and the RAM, it's a random access memory here. And the basic units of memory, it's binary. Right? Binary, that means you can think about the bit here. Bit only store information about 1 and 0 in the computer. Right? So actually, for every computer, every program, ultimately, in order to execute it by the computer, you have to convert it into 0 and 1. You have the sum of the unit here. You have the megabyte, gigabyte, kilobyte here. You have mass storage device, you have HDD, and you have the CD or HDD also. Nowadays, store information in the cloud computing, and you can have infrastructure at the service, platform as a service, and software as a service. Now you have the input. Input, you can list a lot of input here, right? Input can be keyboard, everything you got it from the user here. Keyboard, mouse, digital pen, modem or wireless internet connection, touch screen, joystick, voice command, and more. You can name many of them. And the output, you have monitor, you bring out the output here, printer, speaker, and more. Now the software. So basically for the software, break it down into the two types of software. The first one is application software. Application software is to enhance the productivity, solve the network, solve the problem, supplies information, provide entertainment. You can think about the Microsoft Word, right? Many application software here. Photoshop, Lightroom, and the second one is system software. System software is the most component of the system software is the operating system here, or the firmware. System software, it is everything. It controls the hardware and interface with the end user. So basically, for the computer, you almost cannot do anything without the operating system. Now we learn about the programming and scripting language. Oh, this one I should be doing later. Now, so in the programming, you break it down into two types of programming language. The first one is a low-level language. In the low-level language, the first thing is a machine language. So machine language is only consists of binary 0 and 1. It only work with 0 and 1. And ultimately, for every program, every language, you only have to translate it to the 0 and 1 in order to execute programming, right? So the machine language, it only consists of the 0 and 1. Now see, everything is 0 and 1 here. So in order to do with the low-level language, you have to deep knowledge about the hardware. You have to know everything about the hardware here, and it's not easy for you to understand. That's why they move to the assembly language here, a little bit easier for you to understand. It's symbolic representation of machine language. Think about instead of using 0 and 1 here, now we can use a character here, and A and B, and so on. Now, the second category of the language is a high-level language. Now we know that the low-level language very hard for you to understand, and it is a hardware specific. Hardware specific, that means when you work with the machine language here, if you code it into one computer and you bring it to another computer, it not work because it is hardware specific. Right? So we think about you work with a mouse Logitech, but you work with the another mouse here, it's not work. Right? That's why it is when you work with the machine language here, it is hardware specific. And when you're done with the computer, when you bring to another computer, it will not work. Normally, it's not working. So in order to overcome that, it's just too hard to understand this one. You move to the high-level language. It contains English word and phrase and the expression here. It's easier for you to learn. And the resulting program are easier to read and modify. That's the benefit of the high level here. So what do you think? What is the pro and con of the low level and high level language? What do you think? Tell me, what is the pro and con of the low level here? What is the pro? Yes.
The machine is able to, for the low level languages, the machine is able to understand it much easier. It doesn't have to be converted.
Yeah, right.
Whereas a high language is easier for us to understand, even though the computer has to convert it.
Yes, right. That's the pro and con of the low level. So low level, that means you work directly with the hardware, right? So you do not have to translate it. It works very fast. Here. But the con is that it is a hardware specific. So you have to deep understanding about the hardware, and also when you bring from the one computer to another one, it's not working. But for the high level, the pro is very easy for you to understand. Very easy. But remember one thing here: for any language, ultimately, in order to execute it, the computer have to translate it into the machine language. So with the high level here, it's slow down process. Also, we have to translate it. But a core pro is that easy for you to understand. And again, when you work with a high level language, it can be It's not hardware specific. You can code it and bring it to other computer to run it. Yes. Okay, so understanding about computer system, you have the programming language. Yeah, you have to write the computer instruction called programming code here. Writing instruction is a coding program. You have many high-level language nowadays. You have Visual Basic, C#, C++, and Java or Python here. Now we go with a definition of syntax. Syntax is a set of the rule. Set of the rule to governing the word usage and punctuation here. And mistake in language are the syntax error. So whenever you code the program, if you got the syntax error, program stop. And until you fix and find the fixed error, otherwise it always stops here. And so your duty, you have to find out what is syntax error, you have to fix it to have program executed. Now, in the high-level language, remember that in the high-level language, in order to execute program, you always have to convert it, translate it into the machine language. And you have two ways to convert it, to translate it into the machine language. It is a compiler or interpreter here. So I think I have the video here for the difference between the compiler. What is it? This one.
A programming language is a formal language designed to communicate instructions to a computer. There are two major types of programming languages: low-level languages and high-level languages. Low-level languages are referred to as low because they are very close to how different hardware elements of a computer actually communicate with each other. Low-level languages are machine-oriented and require extensive knowledge of computer hardware and its configuration. There are two categories of low-level languages: machine language and assembly language. Machine language, or machine code, is the only language that is directly understood by the computer, and it does not need to be translated. All instructions use binary notation and are written as a string of ones and zeros. A program instruction in machine language may look something like this. Technically speaking, this is the only language computer hardware understands. However, binary notation is very difficult for humans to understand. This is where assembly languages come in. An assembly language is the first step to improve programming structure and make machine language more readable by humans. An assembly language consists of a set of symbols and letters. A translator is required to translate the assembly language to machine language. This translator program is called the assembler. It can be called the second-generation language since it no longer uses ones and zeros to write instructions, but terms like move, add, sub, and end. Many of the earliest computer programs were written in assembly languages. Most programmers today don't use assembly languages very often, but they are still used for applications like operating systems of electronic devices and technical applications, which use very precise timing or optimization of computer resources. While easier than machine code, assembly languages are still pretty difficult to understand. This is why high-level languages have been developed. A high-level language is a programming language that uses English and mathematical symbols, like plus, minus, percent, and many others, in its instructions. When using the term programming languages, most people are actually referring to high-level languages. High-level languages are the languages most often used by programmers to write programs. Examples of high-level languages are C++, Fortran, Java, and Python. To get a flavor of what a high-level language actually looks like, consider an ATM machine where someone wants to make a withdrawal of $100. This amount needs to be compared to the account balance to make sure there are enough funds. The instruction in a high-level computer language would look something like this. X equals 100. If balance less than X, print insufficient balance, else, print please take your money. This is not exactly how real people communicate, but it is much easier to follow than a series of ones and zeros in binary code. There are a number of advantages to high-level languages. The first advantage is that high-level languages are much closer to the logic of a human language. A high-level language uses a set of rules that dictate how words and symbols can be put together to form a program. Learning a high-level language is not unlike learning another human language. You need to learn vocabulary and grammar so you can make sentences. To learn a programming language, you need to learn commands, syntax, and logic, which correspond closely to vocabulary and grammar. The second advantage is that the code of most high-level languages is portable, and the same code can run on different hardware. Both machine code and assembly languages are hardware-specific and not portable. This means that the machine code used to run a program on one specific computer needs to be modified to run on another computer. Portable code in a high-level language can run on multiple computer systems without modification. However, modifications to code in high-level languages may be necessary because of the operating system. For example, programs written for Windows typically don't run on a Mac. A high-level language cannot be understood directly by a computer, and it needs to be translated into machine code. There are two ways to do this, and they are related to how the program is executed.
And so we talk about the translate, right? So every program, in order to execute on a computer, you have to translate it into machine code. And you have two ways to do that. The first one is the compiling. The second one is interpreting it.
A high-level language can be compiled or interpreted. A compiler is a computer program that translates a program written in a high-level language to the machine language of a computer. The high-level program is referred to as the source code. A typical computer program processes some type of input data to produce output data. The compiler is used to translate source code into machine code or compiled code. This does not yet use any of the input data. When the compiled code is executed, referred to as running the program processes the input data to produce the desired output. When using a compiler, the entire source code needs to be compiled before the program can be executed. The resulting machine code is typically a compiled file, such as a file with an exe extension. Once you have a compiled file, you can run the program over and over again without having to compile it again. If you have multiple inputs that require processing, you run the compiled code as many times as needed. An interpreter is a computer program that simulates a computer that understands a high-level language. This means that the interpreter translates the source code line by line during execution. Consider again a computer program that processes some type of input data to produce output data. The interpreter executes the code line by line, which results in the desired output data. The only result is the output data. There is no compiled code. When using an interpreter, every time you want to run the program, you need to interpret the code again, line by line. There is no compiled code to use if you have multiple inputs that require processing. To understand the difference between compiling and interpreting, let's examine the equivalent in human languages. For example, consider a movie made in Asia where all the characters speak Vietnamese. To market the movie to an international audience, the spoken text needs to be translated into English. A translator would sit down and carefully translate all the text and create subtitles for the movie. Anytime someone wants to watch the movie, they can turn on the subtitles. This type of translation is the equivalent of compiling. Everything is translated once and can be used many times afterwards. Now consider a delegate from Vietnam giving a speech in the United Nations in Vietnamese. In order for the attendees to understand the speech, there are a number of translators who provide a translation that is transmitted to the attendees' headphones. This translation occurs close to real time. Every time the delegate speaks in Vietnamese, the translators get to work. This type of translation is the equivalent of interpreting. Text is translated line by line as necessary, and the results are not used again. Compiled code tends to be faster since the translation is completed in one step prior to the actual execution. Interpreted code, on the other hand, is more flexible and can be run interactively. For example, using interpreted code, you can try out a few lines of code to see if they work very quickly without having to go through the steps of compiling and executing the program. One advantage of using compiled code is that it does not reveal the original source code. This makes it possible to distribute a program without revealing its inner workings. When you install a software application on your computer, you are typically installing a compiled version of the code. You can run the software application, but you can't open up the source code in the original programming language. For many companies selling software applications, the original source code is a well-kept secret and gives them their competitive advantage over other companies. Examples of compiled languages include C and its derivatives, C++ and C#, COBOL, and Fortran. Examples of interpreted languages are Java, Perl, Python, and Ruby.
Okay, so
There are two major types of programming languages, low-level languages and high-level languages. Low-level languages are machine-oriented and require extensive knowledge of computer hardware and its configuration.
okay. So basically for the program, you have the two basic type error here. The first one is the logical error. The logical error is an error in the program logic producing incorrect output. So to understand about the logical error, you have so for the logical error here, I mean, do it again. Okay, for the let's see. Okay, so you can think about this one. Let me do some more solution here. Hello, can you see my screen? Okay, so we can think about this one. Then very hard for you to see, right? I don't know. Is this one? Okay. Sorry. Zoom it here. Sorry. Okay, so if you look on this program, it's very simple program. For now, you don't have to understand the logic here. Right? The program here has want to get two input from user. The number one and the number two here, and I store it into the variable x and y. Right? And I want to print out what is the sum of x and y here. Right? So now you can see that right now I run program here. If I run this program. Here. So I put the number 10, and the number 20, and the sum is the 30 here. The program is run for here, right? But what happened? You have the two types of the error here. The first one is the logical error, and the second one is a syntax error here. So the logical error is the one when you execute program, it runs smoothly. But the output is not what you expected here. Now see what happened here. I want to print out the sum, but instead of print out the x plus y, I do minus y here. So see, if I enter the number 20 here and number 10 here, right? So basically for this program, if I want to print out the sum, I expect number is the 30, right? But this program here, I make mistake. It is a logical error. Instead of plus, I put a minus here. So you see, when instead of the correct output, I expect the 30 here, but now the output is a 10. Right? So that is an example of the logical error. So remember, for the logical error, the program runs execute normally, but the output is not what it expected here. So for that reason, whenever you do anything with the coding, you have the testing step to make sure that the output is what it expected. Right? So that is an example of the logical error. Now the second error is a syntax error. So if you have a program, if you have a syntax error, it will stop the program. It cannot execute until you fix it. You try to fix it. Now see what happened here. If I fix this one, I remove this one, right? And I run it here. When I run it here, see, it tells me that I have the syntax error here. I have the syntax error here. Right? Because this one is never closed. So basically, you need one more parenthesis for this one. Right? So remember, for now, you have to understand. Basically, you have two types of error: logic error run smoothly, but the output is not what you expected. And the syntax error program is stopped until you try and fix it. Okay, make sense? Hello. Now. Another one we talk about is variable here. So what is a variable? Variable in the computer is something I think about. You have the what is this? This one. Okay, so variable in the computer logic, it is a name memory location whose number can vary here, right? So think about if you write the program here and I don't know what happened in this one. Let's change here. You think about this one. The variable is a name memory location whose value can vary, right? So think about you have the program. I don't know. Yes, you have a program, and you have a side value x here equal to 10 here. So suppose that I have to do it here. I don't know why I cannot do it here. Are you? So think about you have the program you put the x number equal to 10 here. So what happened with this one? Actually, for this one, the computer rules here. It reserves one slot in the memory. It reserves one slot in the memory. And the name of the memory here is x here. That's the name of memory. Right? So whenever you call the variable x, it refers to the slot in the memory. It's a slot in memory here. So what happened here? If I put y equal to x plus 10 here, 3 here, right? Think about this one. The first thing, if I put x equal to 10, it reserves one slot in memory and it store value of the 10 into the memory slot here. Right? And now when I put y equal to x plus 3, it refers to the slot in the memory. It take out the value of the 10 and it plus the 3 here. That's why for now I have another memory. And the name of memory here is y, and it stores the value of the 13 here. It makes sense. So the variable is something you tell. It's a variable. That means it's changeable. It's changeable, right? So you can assign the number 10. Now next time you can assign it to the number 20 or 30, whatever. It's changeable, right? Now think about this one. If I have program here, if I have program that I put x equal to 10. Now I put x equal to 20. And now I want to figure out y equal to x plus x here. What do you think? What is the value of y now? What is the value of y now? Oh, I think it should be better. I change the color here. Now think about this one. You have x equal to 10, and I have x equal to 20, and I want to figure out y equal to x plus x. Now, what do you think? What's the value of y now?
It won't work.
What? Why?
Two of the same variable.
What do you think? What's the value of y? What is the value of y? Y equal to x plus x. Yes, 40. The thing is that the variable is changeable. And whenever you reassign the value, it will override the previous one here, right? So think about this one here. Now, the process here. The first time you assign this one, you have the slot here. Slot's name is x, right? You put the number 10 here, right? Now the second one, you put x equal to 20. Remember, it will override the previous one. So now I change it to the 20 here, right? So now we'll see. When you put y equal to x, what's the x reference to this slot here? Takes out the 20 here, and what's the y here? Reference to the same, right? And take out the 20 here, and you plus them together. That's why you have 40. Okay, so that is the variable you have to remember. The variable is the reference to the one specific slot in the memory. And whenever you use it, use the reference to this slot and take it out. And it is a very, right? It's a variable, very changeable. So whenever you update it, you assign the value, it will override the previous one. That's the thing you have to understand about the variable. Okay, now You understanding about the programming development cycle. So basically, for every program, you have the sum of the cycle here. And the first one, you have understanding the program. Now you have to plan the logic. You code program. You use a software, compiler, or interpreter here to translate the program into the machine language. Test program to make sure it is expected here. And put program into production and then maintain the program. So the reason it's called a cycle. Cycle that means at any time, if you find anything going wrong, you can come back and to fix it. That is a cycle. Iteration here, iterative, right? So we think about this one here. You can think about program and development cycle. You can think about my wife. She gave me the order that make me some cookies. Right? The cookies here. So the first thing you have to understand program. What is the problem here? She wants to make some cookies. That is expected output. Right? So basically, for every program, you can think about you have three basic elements in every program: inputs, processing, and output. Right? So for this program, the expected output here it is make some cookies. Right? But here, the thing about this one, for understanding problem and planning logic here, it is two major steps, two very important steps in the cycle here. Right? So you have to very specific and very in detail for the understanding problem and planning. The better you prepare for this two steps, the better the success you have. You think about this one. I give my comment from my voice. Make her some cookie, right? Oh, it says that it's too easy. Please, okay. I cook it and mix it and bake it. Now she said, no, I want 10 instead of 5, right? I want something crunchy here. Right? I want something I don't want it too soft here. I want something crunchy here. That is a problem. And that is thing of understanding problem. You have to very detailed and you have to pay a lot of attention in understanding problem. The more specific you have, the more chance of success you have the program. Right? So you understanding program, plan logic. That means when you specify that she wants the 10 cookies, she wants chocolate chip, she wants crunchy, right? You have to do everything in the recipe here, step by step. Right? The first one, I had to buy the flour, the milk, the chocolate chip, and everything, right? And you have to follow the step, mix the milk and the flour together, and so on. That also very important. Right? That also very important here. That is the two most major important steps in the development cycle. That's even better. Right? So again, when you've done everything with the understanding problem and the planning logic, use the code program. Actually, the code program is a simple step. You understand the logic, you just convert it into the specific programming language. Right? And you can use a compiler or interpreter to translate it into the machine language. That's program also important. You have to make sure you have a lot of static to make sure it is expected output. Right? Now think about this simple program here. I want to figure out what is the division of two numbers. Right? You can think about. I get the first one. I think about this one here. Come back to my program here. Now think about this one. I run the program, right? I have to fix this first. I have the 10, have 2, and now division is 5. Work correctly, right? But what happened here? What happened? I run it again. I run it again. I put number 10 here, but I put number 0 here. See? I got the error here. Right? That is something is very important. You have to pay attention in the testing. You have to figure out all of the scenario you might cope during the program. Right? So for this one, you cannot divide by 0. You have to do some of the exception, or you have to do some improvement in the program. Okay, so that is about the programming development cycle here, understanding the problem. plan the logic. The two most major important steps in the cycle. And you write the code, translate into the code, test program, code program into introduction, and the maintain program. And the reason it's a cycle because any step, if you find something wrong, you can come back here. And the earlier you detect something wrong, the better for you, right? Because the later it takes too much time and resources. Okay, and understanding the problem, what is the most important aspect program, user or the end user? It is a people for whom program is written. And the documentation is all supporting paperwork for program. Like you think about you buy a game, right? You always have the documentation. You have the instruction, you have the help here. Now, about the planning the logic, right? The planning, the step of program, you know that in order to do the program, you have to understand the logic. The second one, you have the plan, right? The plan it is a process of writing down the algorithm. So the complex program, you have many algorithms. So what is algorithm? Algorithm is a sequence step or rule. Specifically, the first step, the second step, the third step, what you have to do. Right? That is a sequence of steps and rule you follow to solve the problem. To solve problem here. And the most common planning tool is a flowchart and pseudocode. I will go over what is a flowchart and what is a pseudocode later today. It's a checking here. So you have to list down what is a testing scenario you have to test after you done every program.
Buy 4 tires and get up to $250 in savings after rebate at Bell Tire's Labor Day sale.
Our new Duracell Optimum battery with Power Boost ingredients takes up to 350 more pictures.
What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode, English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so, by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people one at a time, we instead count them 2 at a time. This algorithm's just twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all since there aren't any pairs of people in the room. And so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2. But then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm is said to be buggy because it has a mistake. Let's redress with some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition, otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, this algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s, but beyond that, it's going to get a little bit difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
Okay, so in short, is that understand the algorithm is a set of instruction, the set of the rule you follow, and giving out the specific problem, right? Yes, coding is easier than the planning step. So again, very important that you have understand problem and the planning step. Okay, and translation program, compiler or interpreter go over already, right? And you have the syntax error. Remember that you have syntax error program stop until you fix it here. And how it works, how it translate it here. We write the code program and the compile program, and for compile is where you check for any syntax error here, right? So when you fix all of the syntax error, I go to the executable program here, and when you run program, every time it got the input from user and it giving out the specific output. Logical error, I mentioned it already. Debugging is the process of finding and correcting the program error. So that's why you have some of the assignment is the debugging exercise. You have to locate it and to find out what are the syntax error, what are the logical error, and you have to find and correct it here. The process-dependent program conversion is the entire process of action take the switch over to the program here. And maintenance is the last step, right? So when you go to the production, you also have to follow it here. Something you have to, you might have some patch or some of the correction here. Now you have the pseudocode. And in this class, most of the time we use the pseudocode and flowchart. You have some a little bit work with the Python, but you do not have to install Python. Actually, you work on the virtual machine. You link to the SendGate and do with the virtual machine in the SendGate here. So most of the time for this class, you work with the pseudocode and the flowchart here. So what is pseudocode? Pseudocode, actually, you have to remember pseudocode is not actual programming language. It's not actual programming. It is an English-like representation of the logical step. So normally they do it during the planning step here, right? No, that is so problem. And the flowchart, it is something with a pictorial representation of logical step. It tries to solve problem here. Now you can think about this one. This is a very simple pseudocode here. This is very simple pseudocode, right? So remember again, as that I mentioned that for any program, normally you have. I have to give up this. For any program, you have the inputs, you have processing and output. So this is very simple pseudocode program. You've got the input from user. It is a number here, right? And you have to figure out what is a number doubling here. That means you times it by 2 and print it out here. So here it is a format as a pseudocode. For any pseudocode, you have to start and stop here. That's the program is pseudocode, right? And whenever you want to get input from user, you use the keyword input here. Input here, my number here is a variable, right? That means you store whatever the user enter into the variable my number here, right? And now you double it, so we set my number equal to my number equal to, and now the last one user take it out. So the process is that here. The process of this one is that one. You have the variable here, my number. You have my number here. And you got input from user. So the first time he can enter the number 10, the next time he can enter 20 and the 30 and so on. Right? And the next step here, you have the my answer equal to my number. That means you have one more variable, my answer here. Right? You have one more my answer. Remember that variable, it is a slot memory, and reference to the slot memory, right? So now it depends, right? If the user enter number 10 here, it assign my answer equal to my number. What's my number? Reference to number 10. And time it to 2. That's why it's stored here, 20. Right? So store here is 20. And the last one, user take it out, print out. My answer is 20. Right? So that is very, very simple. A pseudocode program, remember. You have start and stop. You have input, got input from user, right? You do anything with the processing, you have a set here. And if you want to print it out, you should use the output. That is very simple program. The pseudocode. Now, about the flow chart. So flow chart, it is something about the graphical here, right? So basically, in the flow chart, you have input symbol here. It indicates the input operation. It parallel logogram here. That is when you see the input here. Right? That is input. Everything about processing, you see about rectangle. Everything about the processing about the rectangle here. And the output also, output you have parallel logogram here. See, that's the output here. So we see for this one on the right here, it's a pseudocode. It is a pseudocode here on the right. And on the left here, it is a flow chart. So when you understand the basic of the flow chart and the basic of pseudocode, you can easily convert it into the real programming language. I see. On this one here, if I click on this one. What is screen? Hello? This one. Yeah. Now we see with this one. This one I work with the Raptor here. The Raptor again, it is not real programming language here. Right? So when you click on this one, I think it should be better. Okay, so for this program here, right? So again, you see, I have 3 steps here. Input here. Right? I got the input. It is a parallel logogram here. Right? And I got processing in the rectangle here. And this one parallel logogram is the output here. So basically, when you work the Raptor, you see, when I run this program, I click on this one here. Enter the number. I put the number 10 here. And I do processing. You see, I have my answer, the 20 here, and it print out 20. Right? That is when you work with the Raptor here. And again, once you are understanding about the logic of the flowchart and the pseudocode, it's very easy for you to convert into the real programming language here. Think about this one. This one I work with a Python here. Right? So see, I got input, right? I got input from user. That I have input here. I do processing, and I print out my answer here. Right? So when I run it here, Okay, so print out the positive. Now, that is the process when we work with pseudocode and interrupter here. And sorry, with flowchart here. Now see, if you look on the left, it is my program, it's a preread program, right? I got input from user. Input my number here, my answer, and the output here. Now the thing about the one. If you run again with the interrupter here, if I run again with interrupter here, let's see what this one. Okay, now see. If I run this program, you see, yeah.
Online, they can't see that screen.
Okay, so I think, sorry for that. Let me see now.
Yes.
Okay, now if you look on this program, here, you see, I don't know what I have to do. Right? So what happens if I enter the character A or enter hello world over here, right? That is not really make sense. So in order to make the program to make more sense to the end user, you have to put on prompt. Prompt is a text to tell user what you have to do here. Right? So think about this one. Instead of this one, I can modify it here. I can modify my program here. I can modify program here. So please enter the number. Now I run it again. It makes more sense, right? It makes more sense here because it tells the user here what is expected to do here, right? So remember that whenever you code the program, try to make it meaningful prompt. Right? You have to think about you as the end user here. You see the program and you tell the user what he have to do here. So now what I enter the number 10 here. What happened here? See, it print out the number 20 here. Okay, it's not really make sense, right? So in order to make it more sense, you have to put the prompt here also. I put your number, the number when you time by 2 is here. I can correct it here. So see. Okay, so I run it again. I put the number 10 here. Okay, so see, it makes more sense, right? It makes more sense. So again, that is good. That is good habit when you work with the code. Try to include the meaningful prompt in the program. Now I come back to my slide here. This one, of course, it works. It works, right? I run it again already. It works, but it's not really make sense to them. So whenever you program, try to add the meaningful prompt and the output here. Now see, instead of the input my number here, now you have the prompt here. Now enter a number, right? And you got it from the user and got the my answer. Now instead of output my answer only, I have the prompt here, my answer. Right? It makes more sense. It makes more sense program. Now see. And I run this program again, right? When I run this program here. Actually here, I see. It's not tell me anything. It's not tell me anything with this one. Right? So it should be better that you have to run it again. Oh, I think it's the tab. Now, I modify my program, right? I modify my program here. I cannot open it. Okay, so here's I just want to try mention that whenever you do the program, try to make it. Try to make it more meaningful. Okay, so in the program, you have the sum of the common problem. The first one is repeating instruction here, right? It is. Right, so for this program, you see, you just do it one time, right? You got the number and double it and bring out the answer. What happens if I do it for multiple times? Right? So I have to code it again, my number again, and get input number, figure out what is my answer again, right? You have to do it for many times. I think about this one here. You can do it, yes, of course, you can do it here, right? You do it the first time, you do it the second time, and you do it the third time. But what happens if you want to do it 1,000 times? A lot of coding, right? So that's why the reason you do with the looping here. So what is the looping? Looping in the programming is that you create a loop. It's a, or you can call it a repetition here, or the repetition is a loop here. So in the loop, you keep doing it. You just keep doing it, right? But always you have a good program is that you have the condition to check. Right? So for this one here, you see this one here, it runs it again and again and again forever. Because enough, you have no idea when you want to stop program. That is an infinite program, infinite looping. It runs it again forever, right? So for the good program, you always have the condition to check. If it's true, keep doing it. If no, exit the looping. Right? That is the program. Okay, so you can think about this one here. This one, I think this one it is a infinite looping. Okay, so now see this one here. It keep doing it and never end. Yes.
You're not able to see it online.
I keep running.
There we go.
Okay, that's it.
Yep.
Yeah, see, for this program, see, it keep doing it forever. I don't know how to exit it. As that is not good program. That's good looping game. So remember, for the good looping program, you only have the condition to check. If yes, keep doing it. If no, exit it. Right? That's why you come with a definite loop. It has specific number of iterations here. So basically, for the loop, you have two types of loop. You have the two types of loop. The first one is a loop with definite loop with specified number of iterations. Iteration is that each time the program do one time. It's a loop do one time. It's an iteration. Now think about this one. I want to get input from grades of all my students here in the class. This is a specified number of iterations because my class here has 18 students. Right? I know for sure I need to run it 18 times. Right? That is a specified number of iterations. And this is a definite loop with a counter here. So in order to do that, I have to maintain a counter. I start from the 1 and keep doing it. For the next student, I increase by 1. Number 2, right? Next student, I increase by 1. Number 3, and until 18, I exit 0. That it is a specified number of iterations. Right? So we can think about this one here. When you run this one with Raptor, so okay, for every slide, I would have both of the Raptor and Python here for the reference. You want to see it here. Right? So let's see this one here. Right? Just think about this one. I want to run this one for 5 times. This is a specified number, right? That is definitely true. I just make sure I run it only 5 times. So we see, I have, remember, for any specified number of iteration, you have to maintain the counter. You have to maintain the counter. Right? So for this one, I starting from the number 1. Now do it one time. Anytime I do it here, change it to 100 here. Anytime I have to increase the counter by 1. Alright, so the next time, number 2, number 3, number 4, number 5, stop here. As you see, when I run this one there, when I run this one, I do the 10. That is the first time, right? And you look, if you look on the left here, you pay attention to the counter here. It increased by 2 already, right? See, when there's 1 here, when you've done everything, you increase by 1. That's why you change it to number 2 here. Right? So now keep doing it. Keep doing it at number 20. Okay, you see counter number 3 here, right? Number 30. Number 40. Okay, so see, when you go to the number 50, right? The counter 6 here, greater than 5. Exit program. That is definite loop. Definite loop, that means you know for sure how many times you want to run the loop here. How many iterations you want to go. It makes sense? Yeah, that's why you have to maintain the counter here. For this one, you maintain the counter and remember, very important here. Very important here. For any iteration of the loop, you have to take action to change the counter. Otherwise, you need it. Infinite loop. Now, what happened here? What happened here? I delete this one. Now I run it. What happened? I have number 10, 20, 30, 40. See, what happened here? The counter always stay at 1. Right? Because you don't have action to increase the counter here. The counter is always 1. That means it never ever greater than 5. That means it keep doing it forever. It keep doing it forever. That is something that is the most common mistake when you work with a specified loop here. And so remember, when you work with a specified loop, specified number of iterations, maintain the counter, and inside the loop, you have to take action to change the counter. Otherwise, it keep doing it forever. And of course, for the counter here, you can do it on the increase or decrease here. So think about, if you want to decrease, you set the number 5 here, and every time you minus it by 1. And whenever greater and less than 0, you exit. You can do it. You can totally flexible with this one. Okay, that is a that is the current when working with the specified number of iteration or definite loop here. You know for sure how many times you can. The other one, you see, for the definite loop, you always have initialized the counter. I set the counter, the one at the beginning, before the loop. Remember that you have initialized outside the loop. The second one has the condition here. You see, if you look on the router here, right? Initialize the counter. That's the condition here. Take the action to change. Actually, you have to convert it here. Yeah, take the action to change the counter. That is 3 steps you have to totally understand and remember when you work with the loop in the diagram. Initialize the counter, check the condition, change the counter. That's 3 steps. Right? If you miss any one of them, it's not working. Now the second one. Think about, I want to input the grade from my student. My class, I don't know how many students. I want to keep doing it until I want to stop. That means whenever I enter the grade number -1, I stop it. That is an infinite loop. We don't know how many specified number of iterations. That is the next slide here. Okay, the next slide is an indefinite loop with unspecified number of iterations. So when you run it, you don't know how many years. You just keep doing it until you want. You are the one who control how to control exit the loop here. So think about this one here. I run the program here. Now you run the program here. Right? You run the program. For this one, I don't know how many times I want to run it here at the beginning. I just want to keep doing it until I enter the number 0. Right? So see, you have the instruction here. Get the number, check the condition if the number equal to 0 or not. Right? If not, keep doing it, and you have to ask enter again until he enters 0. Right? So see, for this program, I might run it 2 times, 3 times, 5 times, 10 times. Totally up to you. Right? Totally up to you when I want to execute here. Right? So see, when I run this program here, when I run this program here, yes, number 0 here. So I don't want to enter here. Number 10, number 20, number 30. Now see, whenever I want to enter number 0 to exit here. So now if I want to exit, I put the number 0. Now it exits. Yeah, I am the one who control how to exit the loop. And before the loop, I know that I can run it 2 or 3 times or 4 times, whatever. Makes sense? Okay. So the number 0 here, sometimes they call it the sentinel value. That thing about you keep asking user enter the grade, and whenever he enters the -1, exit, right? Because you have no student with the -1 grade here. They call it the sentinel value. Normally, sentinel value is a value never ever happen in the real life. Anyway, exit here. Now, understanding about programming language and user environment. So basically, you can use a text editor. For this program, I don't think you have to. I don't think you have to do with the integrated development environment here, because most of the time you work with pseudocode and Raptor, right? And the only time you work with the Python, but you do not have to do with the IDE here. You log into the SendGate and do it from the SendGate. So basically, this one you do not have to pay attention for this one. Yes, that is okay. Now, understand the evolution of the programming model here. So basically, for the programming model, you have the 2 categories. The first one for procedural programming. The second one is object-oriented programming. Procedural programming that you break down program into a multiple function and the method here. And whenever you want to use it, you just call it out. And in the object-oriented program, that you encapsulate everything into that, and you reduce the dependent between them. I don't want to go into detail for this one because we don't go over this one much. Now, again, for this class, you have to pay attention on pseudocode and Raptor. That's why I have some more slides here to instruct you how to work with the pseudocode and the Raptor here. Now, about the pseudocode. You want to take a short break and come back, or you can go on? Short break? Okay, so we take about 10 minutes. Okay. Okay, so now we go on. Okay, in this class, most of the time we work with pseudocode and Raptor. So now I have this some of the basic slide or basic introduction to the pseudocode here. Okay, pseudocode is not real programming language. It's artificial and informal language that help programmer develop algorithm. So basically, it's very helpful in the step of the planning. You do the planning. And for every program, you have the 3 basic elements in every program. input. You got input from end user. You do processing, everything is calculation formula, and giving out the output here. Expected desired output here. Right? So now I have program here. Right? I have a program here. If you want, you have to write a program that in that a shop owner who sells ball, each of them is a profile here. And you have to develop a program to ask user to seller to enter how many balls he sell for 1 day, and from that you have to figure out how much money you earn. Right? So again, in every program you have to find out 3 things here: input, processing, and output here. Now, if you look on this one, if you look on this program, what do you think? What is the expected output for this program? What is the expected output? What do you think? What is the expected output? How much money? Huh? How much money? And you can store it in what variable name? The variable here, variable name, it doesn't matter. You can put it's a money or revenue or whatever. But you have to find out. You have to figure out what. So the thing you want here is to find out how much money you are there, right? So from how much money, what do you need? What do you need input here in order to find out how much money? What do you need input? What do you need from the user input here?
The amount of balls.
Yeah, that's the number of balls, right? So yes, that's a very simple program. But for any program, I just want you to identify the 3 elements here. The first thing you have to do in the reverse way. What is the expected output? The first thing you have to raise the question, what is the expected output? Now, from expected output, you have to find out what do you need? What do you need from input in order to find out what is the output here, right? So for this one, the expected output is how much money. And in order to find out how much money, you need to get input how many balls, right? And the calculation here is very simple. For each ball is a 5. That's why you have the ball times 5 here. Now, when you have the program here, you convert it into pseudocode. It's very simple here. Pseudocode, you have start and stop. That's the program, right? You have the declaration here. In this one, you need 3 variables. Right? Expected output is revenue. Right? Sorry, you need two variables. Sorry. Expected output here revenue. And in order to find out revenue, you need a number of balls. Right? That's why for this one, that's why for this one, you need 2 variables. This one here is expected output. This output, right? And this one is input here. Now, that's the process of declare the variable you use here. Now, the next step, you got input from user. And you use the keyword here, input here. And it's stored into the ball here, the variable here. Right? So you see, after this step here, actually you have to slot in the memory with the name is ball here. And after the step, you ask user input ball. That means it depends on the user. He might enter the number 10 or number 5. You store it into the variable float here. Right? So next step here, you figure out what the revenue here. So that means you have one more slot here, revenue here. And you assign it to the value of ball. What is it? Take it out from this one. Take it out from this one. A time to find, that means you have the 50 here. Now, after this step, you figure out revenue with the 50 here. The next one, the last step, you take it out from the slot, you print it out to the end user. That is how much money here, right? That's why you have to use the keyword output here, and you take it out from this one and you print it out the 50 here. That is a very simple achievable. Any question for this one? So here in interrupter, you do it very simple here. You get the ball, revenue, and print out the revenue here. But again, remember that for any program, try to integrate meaningful prompt here. This one is not workable. If you run for this program here, if you run this program here, let me do it here. If you run this program, It's not good program. Even the see, I don't know what happened here. I don't know what I have to do here, right? So again, for any program, try to implement it. Meaningful problem, right? So I make some improvement here. I make some improvement for this one, right? I make some improvement for this one here. I integrated the prompt here, right? See, and the number both. So for today, it makes more sense, right? And it put also for the output here, revenue for today is it makes more sense when I run this program. Right? So see, when I run this program again, right? This one. Let me start run it again. It have from here. Now enter the number. I know that I have to enter the number here, right? And 30 here, and you see, I store the value 150 here into the variable revenue, and the last one you just print it out here. Today revenue is 150. So if you look on the data here, you see this one is variable, right? This one is variable. This one is variable, right? So you see, you got it stored into the 30 here, into variable, right? And do calculation, you store the 150 here into the revenue, and the last one you want to. The last one. And the last one is just print it out here, and you see you include all of the string and the variable here to make it more sense in the program. Now you have new problem. Now the shop owner want to change the price of each ball to the 5 instead of 5. Now you change it to 6 to make more profit. Otherwise, you cannot work with here. So how will modify the program? Go back to the program. How will modify it? If now instead of 5 for each ball, now he has 6. So how will modify this program? What do you think? Why it modifies? Yes.
Change the 5 to 6.
Yes, that's all right. Change the 5 to 6 now. So see, you make a change here. Now the 5 he cannot make any profit. He change it to the 6 here. That's all. That is the first problem here. See, you change it from 5 to 6 here. Now the second problem. Every time you want to change it to 6, 7, 8, the shop owner have to call you, right? You as a programmer, you have to come to change it in the program here. He doesn't want to. He doesn't want to do it anymore. He want an option to give him the option that he had the authorization to change it by himself. So how we modify this program? What do you think? How we modify this program to give the shop owner option to change the price of the ball instead of every time he have to call you to come to change it. What do you think? What do you think? What is it?
Creating a variable.
Yes, you need one more variable. Now you see the price not stay at 5 or 6 anymore. 5 or 6 here they call it constant. Constant, that means never ever change. Constant here, never ever change. All right. But now he want the option to change it to the 7 to 8 or not. It is variable, right? So now in order to do that, you need one more variable. So now you have to change program. The output is the same, right? How much money? But now you need 2 variables. You need 2 input variables. The first one, number of ball. The second one, price. Right? So price here, he can enter 5, 6, or 7, or 8. It's totally up to him, right? So see, for this one here. So this one here, I change it here. See, now I have one more variable here. The ball the same, right? The ball the same, the revenue the same, but I need one variable, price. And I need to get it from user, right? I need to get it from user. That's why I have the output here and the price for each ball, and it's stored in the price here. So now you see, I have one variable name, ball. I have the one more variable, price. And I have the I have revenue here. This one is output and this one is input. Now, how many ball? 5. What's the price for each ball? 8 here. Pick it up. 40 here. Make sense? Okay, so you have to adapt to the program. You have to understand what the requirement is in order to modify the program. So see, for this one here, when you run with the Raptor here, sorry, not this one is a Python. I don't want to run it as a Python because both of the program. Now see, you need number ball. You need number. What is the price here? Right now. So you can run it here. You can run it here. You are so for 100. Now each of them 8 here. Okay, so see, ball 100, price 8, revenue 800. You have to print it out. That's why you have the 2-day revenue. You accept to the revenue here and take it out 800. Make sense? Okay. Okay, now we go with a logical error and syntax error here. That is on the first module debugging exercise. You see many of them, and you are supposed to correct it. Yeah, right. Logic error again. Program work smoothly, run smoothly, but the output is not what it expected. So think about this one here. This program, instead of figuring out the revenue, the ball top 5 here. Each ball is 5, right? And top 5. I do the ball plate 5 here. When you run this, it works perfectly. It runs, but the output is not what it expected. I see. I know. I see. Think about this one. I come back to this one. I modify this one. I think this one. Instead of the number here, I put here. Now, see. Run it. I have 100 here. I have I expected that when I sold for 100, I expected output is 500. But now I make mistake in this one. That's why output here is 101. It's not what I expected. Even though that program runs smoothly, right? That you have to find out, and that is the reason that you only have to do the testing scenario for any program. You have to find out what is the test number 1, what is the test number 2, and so on. And to see the output is what you expected or not. Right? That is a logical error. Now the second one is okay, syntax error here. Syntax error is the program stop. Now see what happened with this one here. What's happened with this program here? Change it back to the top here. Now I run this one. 100 here. I got syntax error. Variable ball not found. What happened here? Because you see in this program, where am I? See in this program here, right? In this program here, I store the number ball into the variable name ball S here. But when I call it revenue equal to the ball, it reference to nowhere because the variable here is not the same. So remember one thing here. When you use the variable, you have to be consistent to variable name. Otherwise, you got the syntax error here. So that is also one of the most common mistakes when you work with programming. And you see in the debugging exercise. So in the module 1 of the debugging exercise, you are supposed you have to find out what is a logical error and what is syntax error. Right? Because the thing here, they are not consistent. The ball here actually is at here. Right? Make sense? And so the last one, again, pseudocode is not the real programming language. It's only the artificial and informal language. It's very helpful in the case of the planning. But the thing is that once you understand the logic of the pseudocode, it's very easy for you to convert it into the real programming language. Now we think about this one here. I read in the pseudocode here, and I want to convert in the Python very simple here, right? I just convert it. I need to enter the ball. I need to enter the price. I figure out the revenue. I print down what is the revenue by the Python. Right? So I think that's all for the pseudocode. Now you go with the Raptor here. This one also you work a lot with Raptor. Again, the Raptor just do the same. You have the 3 elements in the every Raptor program: input, assignment, and output here. Okay, you do the same. I got the same program here. Sell the ball here. Now, can you open the Raptor in your computer? I think that every computer now already has the Raptor here. You just search and you put the Raptor here. Yes, click on the. Oh no. Okay, so stop it. Let me do here. So we go to the web. You have to put here Raptor download here. Yes, so the first one here. You see Raptor material. This one here, right? Click on this one. After download. Yes, the first one. Yes. So you click on this one. You have many options to run the Raptor here. And one of the option here is very simple here. The portable version. The portable version. You click on this one. And you click on the portable version and click on the download here. And you save it. You save it. Have you downloaded? Yeah, portable version. Portable version here. This one. Yeah. No. Can you go back? Yes. Click on download. Yes. Yeah. Okay. Okay. Next. Click on. Can go to Raptor again. You can search. Yes. Click on. I think you have to do it again. So. Yeah. And when you're done, click on the run after. Yeah, click on it. Yeah. Yes. Yes. Yeah, click on this one. Okay. Next. And click on run. Yeah. Run. Yes, that's it. Yes, right? Yes, that is a Raptor interface.
Because you may have.
Oh, maybe something new. Yeah, if that's what you do have to do. I never tried it again before, so. Yes, scroll down. More. Yes, the second one.
Don't.
Close.
Yeah,
Close. And save. And click it. Okay. And next. So I click on this one. Okay. So now you see that is the interface with the router here. When you open the router, yeah, you see that is interface router. Router is you do the same with the flow chart. You see, you have start and stop, and you have input, you have processing, and you have output here. Now think about this one. I'll come back to this program, right? Again, I have the same program here, right? So again, for this program, I have identified the expected output here, how much money, right? And in order to figure out how much money I need to get input, how many volt, right? So in the router here, when I open the router, you click on the router here, the interface input here, you see, input here, right? And you drag and drop it here, you got the input. I have to set here, and put a test here. And when you right click on this one, you put the edit here. And you see on the top, it is a prompt. It's a prompt, that means I'm always try to make it meaningful prompt here, right? So I put it here, enter the number of flow. And I want to store it into the variable. Right? So the downside here, it is the variable name. I put it as volt. So see, after this step here, that is a prompt, and I get some number from the user, and I store it into the variable name volt here. I click the volt. Okay, so see, after the first step, I got the prompt here. I get the volt here. What's the question here? Yes, of course, do not open the pop-up. See, you're done with the input, right? The next step you do the processing. Processing, right? You have to find out how much money, right? So in the router, in order to do the processing, you do the assignment here. You click on the assignment. You drag and drop it. So you see, in this one here, let me go back to this one. You got the variable volt here. Think about, you have 100 here. Now you want to find out how much money. You store it into the variable revenue here. So this step actually, when you do with the pseudocode, you put the revenue here equal to number of volt times right here. Think about this one. Okay. Now see what happened here. That means you take it out the number 100 here in the volt, you count it 5, and you assign this value to variable revenue here. So in order to do that, you have to set revenue here. Set revenue here. 2, 4 times 5. Okay. Now do it. Yeah. On the top, it is the name of variable. You want to assign the variable, the value, and on the top, on the down, it's a processing here. It assignment here. Now you can see here. Let me do it here. I do it here. I assign it to the goal. Right here. Okay, so now I got input already. I do processing already. The last step, I just want to print it out. So when you do the router print it out, you click on the output here. Drag and drop the output. Click right click here. Now I want to make some from here. The revenue is, and you want to access into the variable name here, revenue here, right? Remember that the text here is anything. Makes sense, right? So or you can tell the money here, whatever it is. Right? Yeah, that's a done with the program here. Right? I got the input, I figured out what's the revenue, and the last one, I figured out what the revenue is. Right? So I run it here. When I run it, I click it. I'm above 100 here. Right? See, the money here is 500. Right? You see how we run here. I get 100 from the user. I store it in the variable name bowl. Right? I do revenue equal to the bowl. It's that means 100 times 5. That's why I have 5. And the last one, I just print it out. I just print it out, and I have print out here. Where is yeah, right? The print out. Okay, so run it. Everything works. Okay, any problems? Just let me know. Okay, now change it. I want to have option for this program to give you the option to get the price for each bowl from the user. To change this program, it's not fine anymore. But I know I want to have option to get the price from the user. How we do it? You need one more variable, right? Do it. Do this one. Yeah, modify this one. You did it, right? Okay, that's great. Yeah, so we store it into the variable native price. Yeah. Was this one? Or this one? Yes. You need one more variable price. No. Do not use nothing. You want to store it in the variable, right? And remember that variable name, you cannot have space in the variable name. That's the one thing I want to mention. Variable, you cannot have space in the variable. So it only the bowl only. It's a put bowl only. That's all. You store it into and you click that. And you have to save it first. Can you see? Yes, that is input, right? Now we do the processing. Processing you have to do with assignment here. You click and drag and drop the assignment. So it should be better next time you open the Zoom meeting also. So we can watch it in the Zoom meeting better than this one. Sometimes it's very hard for you to.
Yeah, I'll be sitting in front of this.
Oh, okay. Or you can open the Zoom meeting.
Everyone in here, what's the?
You have to buy each one. If I sell them, they cost me each. Sell them, make 600 profit.
Now, why do you need two variable here, price and bowl price? Price, that means price for each bowl already.
But you bought it. So you have to buy all the balls, so, right?
If you want to find out the profit, this one.
Yes, that.
Okay, that's the topic. Yeah, I know. Yeah. Huh? Click that. Now, enter the number 4. Yeah, that you got the syntax error because inconsistent memory. Yeah, you have to click on that. You have double click. No, you have to stop it first. Yeah. You double click on this one and change it. No. This one it actually doesn't matter.
Oh, yeah, but
yeah,
it's-
yeah, it's a problem. Now, here I want to mention this something with this program here. And of course, if you want to get it from the user, the price here, right? Change it here. And put price here. Change it. This one not buy anymore. Price here, right? Okay, so now I run it here. 100. It's all say I have 600 here, right? Work that. Now, something I want to mention here. So when you run program, you have a couple of ways to run program. The first one, you click on this one. I click on this one here. That is one. That's what I did before, right? I click on this one. And I do 100 here. Right? And see on the left here, it store 100 on the board, right? The price here, I put the 8 here. On the left, it store the number 8 into the price here, and now revenue 800, and you print it out 800. That is the first one you run program. Now, in some time, if you have the complex program, many steps here, and when you run, you have some error. It should be better you run step by step to find out what wrong with this one here. So in the after, if you want to run step by step, you click on this one here. Now see, I put here 100 here. And so see, now I know that 100 here is the board, right? I click next again, the price here, right? It's all here, and I have 500 here, and it clean up here, right? So step by step running is very helpful in the case you want to debug the program here. It's complicated. And one more mode you can run it here. You can run and click on run here, and click run compile here. It runs very fast. It runs very fast here. So if you program to run compile here, you have 100, you have 5 here. Let's see. With the compile mode here, it's a compile mode. When you run the compile mode, you cannot see anything on the left. You cannot see anything. If you want something run it fast, you do the run compile. But if you want to do step by step to debug exercise, you do this one here, step by step. Yeah. Any question? Yes. This one, you already got the price, not buy anymore. So this one you have to change it here. You have to change it to the price. Yes.
Yeah.
Okay. Now run it again. Yeah. That is the previous. That is something before. Something wrong before. You can clear it. Yes. So whenever you want to, whenever you want to run it again, think about I have 100 here. I have Many. See, that's the problem here. Why am I problem? This one. Okay, so whenever you want to run it again and you want to clear this one, right? Clear the click of clear here. Okay, see. Okay, so any questions so far? Okay. Okay, so I think that's all for today, and we have something to do after this class. The first thing that you have to make sure you have to download and install Router, right? And that's a very important thing you have to do. And let me check the attendance here. Zachary Baker, I hit okay. Zachary D. Hello. I hit. Okay, now. Zachary Barrow, are you here? No. Cameron. William. Here. Redmond, are you here?
Here.
Yeah. Okay. Emiliano, are you here?
Here. Yeah, online.
Okay, so it's okay. Online.
Yeah.
Okay. Riley, are you here? Riley, are you here? Riley not here. Is he Riley here? Hayden, are you here?
Yeah.
Luke, are you here?
Yep, here.
Diego, are you here?
You're
Diego. Okay. Nikuzi, are you here? Okay. Jack, are you here? Jack? No. Jose Luis, are you here? Okay. Martin, are you here? Not here. Nathan, are you here? Nathan? No. Aiden, are you here?
Here.
Okay, so I see you guys on Thursday, and remember you have to download and install Raptor. We have a lot of work with Raptor on. Okay, bye, you guys.